So regarding the strain concept, hope it is clear for you. So let us move on to the next topic in this chapter, that is elastic limit. By looking at the word, you can understand, I hope, what is elastic limit. What is limit? For usually we say, so behave, okay, and you have got a limit. Do not cross your limits, like that we say usually, right? So elastic limit, what is that? Of course, best example I have given already is like a rubber band. If you take, okay, leave it, no, don't want rubber band, let us go for the most precise example. So imagine you're having a pen which has got spring inside, and if you start pulling that spring, no, you can just observe there, if you pull again it regains back, because you have applied less force there, so it regains back its what, initial position. Apply more what, force on that, that particular spring will permanently will be deformed, and again if you try also it won't get back to the initial position. So all the objects which show elastic behavior has got its own what, elastic limit. That means how to define this, elastic limit is defined as the minimum stress for which the object you can say, okay, or the body is permanently deformed. Okay, so I repeat, elastic limit means it is the minimum stress which develops, okay, for which the object is permanently deformed. That means, for example, rubber is not elastic, perfectly elastic body, it's a elastomer, okay, that is has got different name, but let me just take it as a just example. So what is rubber? It is elastomer, its name, okay, its property. It doesn't have exact elastic behavior. So if you ask which one is more elastic, steel or rubber, means answer is actually steel. Okay, that will come to know, we'll learn about some Young's modulus, all those things, that time you can understand that. So right now, just for understanding you easily, I'll take the example of rubber itself. Okay, rubber band, stretch. What happens? Shows elastic behavior initially, but when you pull for longer, what happens? It gets cut. That means rubber has got some limit. Correct? So rubber shows elastic property, but not elastic than steel. Okay, so elastic property means it is not just like stretching thing, that means more elastic. It's not like that. Just for understanding the word elastic, we can give the example of rubber, all those. But when you come across the precise thing like what is elastic property of a body, means it has to undergo stress, strain, all those concepts. Correct? It has got, should be having more, what is that, restoring force inside all the, that particular object. So when all this counts, then it is decided whether the object is elastic or not. Elastic is not something like just stretching. Okay, hope this is clear. So what is elastic limit? Minimum stress developed in an object when it is completely what, deformed, or you can say before it gets deformed also, you can say. Okay, so which definition you want, you can write. So I repeat once again, simple definition: minimum stress developed before the body gets completely deformed. Okay, the limit is there, no, that edge where till there it will get what, get back to the initial. After that, if you cross the limit, what happens? The object will be completely deformed. Okay, so this is all about elastic limit. Definition, you have to write definitions and all. I won't be writing on the board. Okay, so hope you can manage. Next, let us go for, it's like a question we will take. State and explain Hooke's law. How to pronounce? Hooke. Okay, Hooke's law H-O-O-K-E-F-S, law. So one of the most important theory he has given. Based on that theory, nowadays you can see bridges, buildings in civil engineering field. So much of marvels they have done in construction, different type of geometrical shaped buildings, okay, mega structures we can say. All these are actually happening and possible all because of the concept called this. Okay, in engineering stream, that is mechanical engineering, you can see construction of what is that, engines, machineries. For example, industrial revolution. If this concept of mechanical properties of solids and this Hooke's law, all this were not at all been discovered, means of course what we can say, we wouldn't have encountered the industrial revolution. All these things actually slowly started advancing, so they have applied practically. So industrial revolution has taken place, automobiles, engines, wheels, later on in buildings, structures, many more, correct? Yes, all these actually the very much important things which are required in understanding mechanical properties of solids. So state and explain Hooke's law I have given you here. So it is for 1 mark or 2 marks question it is, okay, usually. So here what he explains is, you have to write very clearly, okay, that is within the elastic limit. That means if you take one particular object and you start studying about its behavior and property and all, you should be very careful in defining it. So how to define this Hooke's law is, it's a law or statement. You cannot change this according to your wish. Definition of any terms you can just modulate according to you without changing its meaning, but it's a law, so cannot write your own wish. So within elastic limit, okay, within the elastic limit, stress is directly proportional to strain. In words you have to write, okay, definition. What is that? State and explain Hooke's law. Within the elastic limit, stress is directly proportional to strain. In word you have to write. After writing that word, then you write this formula. That is, stress is proportionality symbol is proportional to strain. And in examination, imagine you forgot to write within the elastic limit. You told that stress is directly proportional to strain. Answer is wrong. Why? Because it is a law. You cannot change the law according to your wish. Okay? So, note down the point. Within the elastic limit, stress is directly proportional to strain. So, when there is a proportionality symbol present, what we usually do is we bring one constant. Okay? So, how we can write this? Stress is equal to, if you remove this proportionality symbol, you should bring constant into strain, or stress by strain is equal to a constant. Okay? Stress by strain is equal to a constant. So what is this constant called? This is called, in the bracket I will write down, the constant which is expressed or mentioned in Hooke's law is something called, constant is modulus of elasticity. So what is the constant here? You can just write C also, no problem. So what is the statement of Hooke's law? Within the elastic limit, stress is directly proportional to strain. Okay. Then, so stress is directly proportional to strain, we got to know. So how to write that in formula? Like this also you can write in equality symbol. Suppose you try to write, it is stress is equal to a constant value into strain, or stress by strain is equal to constant. So what is this constant actually? It has got its own name. What is that? It is a modulus of elasticity, or measure of elastic property which is present in the object. Okay, so take down this neatly. That is about Hooke's law. Okay. Next, let us move on to one of the very important concept. For 2 or 3 marks it will be asked in examination. Hope this is clear for you. So let me erase this. Next, like a question we'll take down. Okay. Draw, very important, usually 2 marks it will be asked. Expected question it is. Okay. Draw typical stress versus strain graph. So the scientists, when they started studying about or discovering about the property and behavior of solids, they have come across this concept like stress, strain, all those. So to understand that more clearly, they plotted a graph where stress is proportional. That means we know within elastic limit it is proportional. All those things they have started plotting a graph. Within the elastic limit, stress is proportional to strain according to whom? Hooke's law. But beyond elastic limit, what happens? Whether you know? Yes, that is why it is being studied. So what we do here, draw typical stress versus strain graph and explain the features. That is a question. Okay. Hope you can see that. Yes. So let us draw the graph. So first quadrant graph, okay. So this is stress along y-axis, along x-axis it is strain. Okay, so this is the coordinates I have drawn. Next graph, let us plot. So let me use some other colors. Okay. After this, yes, this is the graph. Hope you can draw clearly like this. And I will note some of the points here. Okay. One point somewhere here, and one more here, one more here, and one more here. So I will name this as point A. I will name this one as point B. I will name this one as C. I will name this one as D. Okay. Then you draw a dotted parallel line for this line and flower bracket. Flower bracket I have drawn here. Hope it is visible for you. Then you write down it is less than 1%. Somewhere here near to this you write here 30% strain. Okay, that means this D falls somewhere around, the strain is around 30%. That is why, not exactly, somewhere like this you have just nearly this. Okay. Next, let us write down the terms which is present here. So terms which has to be written. So here D means fracture point. Okay, D means fracture point. Next, what is A? Let us see. A means, I will just draw one arrow mark like this. This is proportional limit. Okay, so point A means proportional limit. Then what is B? Let us see. B I will write here. This is elastic limit. Elastic limit. So point B means elastic limit. After C, from C onwards, this is plastic behavior. Okay, here this flower bracket, this part is there, right? Here you write like this, permanent set. Permanent set, or permanently set also you can write down. So draw the graph very neatly. In examination also a neat graph you have to draw. Okay, hope drawing this is finished. Let me explain this. Okay, so when the question is like this, draw typical stress versus strain graph. If it is asked like this means, so systematically you have to answer. Okay, so initially you just do the graph. Thereafter name these points. What is A? Proportional limit. What is B? Elastic limit. What is C? It is a plastic behavior point. What is that position, flower bracket, that particular part of the graph? It is permanent set. So what is D here? Fracture point. Okay, let me explain this. So according to Hooke's law, stress is directly proportional to strain. Whether it is for all the kind of whatever the value of deforming force is applied on a purely elastic body, whether it follows like that, stress is directly proportional to strain? Of course, no. I will give you example. Lift, you know, right? Lift is actually made to move upward or downward by using the strings, correct? Metallic string will be there. Okay, so that particular strings which are attached to that will have its own elastic limit, and it will be written inside the lift maximum how many members? 10 members. If you do one thing, instead of going for 10, if you go 20, 30 people, if you put inside a lift, then what happens? The cable or the string which is actually attached to the motor to the lift, cable will say, metallic cable it is, steel cable it is, okay. What happens? Its elastic limit will be tested, correct? So now what happens? The cable will start stretching because its elastic property is not at all possible to execute there. Why? Because overweight, over what deforming force is applied. That is why nowadays what happens, the lift, when the optimum weight level is maximum, that means it has crossed, the lift won't go up, it will just give some siren or it will make some noise, that means overload, so that people has to come out. Olden days what happens, they used to go vary the mass and all, so the primitive method was there. So in many countries some lifts is being cut and some some of the such incidents has happened. So later on technology improved, so nowadays lift doesn't move at all, suppose weight is exceeded. So one of the best example I can give. So let us take one steel cable, okay. So it shows elastic behavior. That means when you apply large amount of force, it slightly shows elastic behavior, because I told you people that steel shows highest elastic behavior. Till point A, what happens? Okay, leave it. Let us not follow exactly like the physics, okay, like science. Let me go for the basic. That means a rubber, let us say. Of course, rubber is not 100% elastic property. It's an elastomer. Okay, so if you take rubber, imagine slightly you are applying what force. Now what happens? Stretches, comes back. Stretches, comes back. So you can say that whatever strain is developed there, that means change in length, is proportional to the restoring force which is applied. So what happens? It comes back to the initial position. So there is no change of shape after the removal of deforming force. So stress is directly proportional to strain. That is why. So what happens? If stress is directly proportional to strain, means it's a straight line, correct? Till A, this is under what? Proportional limit. That means below A to origin, let us say O, mark here O, origin. From O to A, it is proportionality part of the graph. That means Hooke's law will be applicable between O to A. After this, you can see there, for little amount of stress, there will be large increase in strain, because if it is going like this, means we can say proportional. Now it is going that way, means what happens? Which one is becoming greater here? Strain is becoming greater. So after A, what happens? For small stress, there will be large strain. So what happens? Elastic limit, in the sense the body slightly started to lose its elastic behavior. So what is C now? For example, rubber is stretched more. What happens? Rubber is actually going to lose the elastic behavior. So it will be just elongated. For example, chewing gum you have seen, right? For example, don't want chewing gum because it is perfectly plastic body. Can give the example like chewing gum. Suppose you just pull that, it gets elongated, right? In that way happens to the rubber. That is what I was about to tell you. So don't get confused now. So that means chewing gum is also elastic body? Of course not. It's a perfectly plastic body. Elongation I wanted to tell you. So that is why I have given you that example. So now what happens here? With very difficult, what happens? It shows the elastic behavior. So B, till point B, the object will try to get back to the initial position. That is why elastic limit. After B, what happens? The objects get elongated. It's like the spring you stretched inside the pen, no? Like that. Completely it will be stretched. So what happens? Whether it gets back to initial position? Of course, no. That is why this part is there, right? Which is less than 1%, I have told you. Here, the strain level is there, right? Within 1% it is given here. So, permanently set. That means, when you stretch a rubber, the stretched rubber will be in stretched form itself soon after removing deforming force if you cross B. That means, when you come to see plastic behavior, if you stretch, if it crosses the elastic limit, then it will be stretched in up. That means permanently it will be in the stretched manner. So it shows plastic behavior only till B elastic behavior. That means a steel wire, steel rod. What happens when you apply large amount of force? Of course, it shows elastic behavior slightly. And when you apply more or exert more and more deforming force, of course, what happens? It will be completely deformed if it crosses point C. So what they do actually, the experiment is done in such a way, okay? So they will be using one steel wire, they apply, go on adding mass slowly, and they will remove mass. Then they will check the length of the wire, same means, okay, elastic behavior. Extra mass they go on adding and they will remove the mass. So still it is showing means Hooke's law is applicable. When they apply more and more mass, what happens then? Elongation is becoming more and more. That means it is not getting back to initial position. So we can say it's actually completely a plastic behavior now. So now what happens? After plastic behavior, then go on stretching that. Then ultimately it has to cut, right? That is why it is called fracture point. Here from C to D, the object doesn't get cut, but it gets on stretching. But at one particular point, it's get cut. So this is what the explanation based on the stress versus strain graph. So have a look. So hope the explanation regarding the stress versus strain graph you understood. Okay. So y-axis stress I have taken, x-axis strain I have taken, then the parts in the graph of this variation. How they got this graph is they do the experiment. They take one particular parameter or apparatus, then they start taking the reading. So when they start taking the reading, they started plotting. So the graph has become like this. Okay. So different points they have mentioned. A means proportional limit. B means elastic limit. Proportional limit means till A Hooke's law is applicable. Stress is directly proportional to strain. After A, what happens? Stress is not becoming proportional to strain. There will be large strain value. That means strain is getting stronger than stress. So it is going towards the right side. So more strain will be there for less stress. That is why elastic behavior will start reducing. Till where? Till point B, fine. There will be a limit. That means for its elastic property. Till there, it can manage to get back to the initial position. At C, what happens? Completely plastic behavior starts. So after C, it completely gets elongated or gets changed with the shape. Completely deformed body it becomes. At point D, after that, it gets cut. So this is the explanation regarding what? Regarding the stress versus strain graph. Okay. Hope you understood regarding the stress versus strain graph. Very important. 2 marks. Okay.